Hey everybody, so we have one last topic in body systems to go over in notes, and this is another highly tested topic. So we have the endocrine system, the idea of receptors, and the hormones fitting them on the target tissue. We have the idea that it travels through blood. That's all important. And then we have this concept that I'm going to go over with today. It's also, this one shows up in the Regents a lot. And it's called negative feedback. So I'm going to actually talk about something totally not about the body or biology for a moment. Did you all know that at least most of you have a fire in your basement? You have a furnace or a boiler, most of you, not everybody, but most folks have a furnace in the basement, and there's a fire inside of it. And you use that to heat either water or air that then travels all over the house and goes to radiators that radiate the heat out. So you have either air or some sort of liquid traveling through pipes in your house, and it travels all over the place. It comes to the furnace and it passes through the furnace, and the fire's really, really hot and heats it up so that as it passes back out, and it goes to the furnace, it can radiate that heat out into your house. And that's how you keep your house warm or cool. If you have central air, there's actually a similar idea. But we'll talk about the heater for now. Now, why did I bring that up? Because the concept I'm about to explain is much easier explained with your heater, with heating in your house. So what do you do when it gets, when it's too cold in your house? Your parents probably don't want you to do it. What am I made of money? Don't touch the thermostat, right? The thermostat is what you would change the temperature, right? If you think it's really cold, you might turn it up, right? Let's say up here in the house, it's 66 degrees, and you're like, 66 degrees. I want it to be like the tropics in here. Let's put it on 75, right? So you turn this little thing to 75, and somehow magically the house gets warm, right? Well, the way that works is that sends a message through wiring down to the furnace, right? This is connected. So what that does, sitting up here, it's set to 75. It's like, wow, it's only 66, and I'm set to go at 75. So I'm going to send a message to the furnace to turn on. And so the furnace, the gas goes into it, and it lights up, and the heat, you can sometimes hear it if you go in the basement. There's kind of like a whooshing sound, right? If you have a furnace. And it heats the water or the air that's going to be passed around. And it starts passing around, and it gets warmer. Warms up. Oh my gosh, time to put on some shorts. It's so comfy. And it's warmer and it's warmer. And then the thermostat's like, whoa, it's 75 in here. And they set it for 75. It's warm enough, and sends a message down to the furnace, turn off, and the furnace turns off. It's nice and toasty. But your house isn't perfectly insulated, and some of the heat gets out, and the temperature comes down, and eventually it gets low enough that the furnace is like, whoa, it's not 75 in here anymore. I'm going to send a message to the furnace to turn back on. That's negative feedback. The thing that's being controlled, the temperature, is controlling the controller. So if the temperature drops, it tells its own switch to increase the heat. When it warms up, it tells its own switch to stop producing heat, and that's negative feedback. And our body does very much the same thing. If you look at so many different of our functions, here's a perfect example with us getting hot and cold. If you start to get chilly, you start to, your brain tells your body muscles to shiver, because then you'll increase your rate of respiration and produce more heat, and you'll warm up. And if you start to get too hot, your brain sends a message to various parts of your skin to sweat, and that cools you, and your temperature comes down. And it's the same idea. It's the temperature itself that signals to the brain whether to turn on or off, and that's negative feedback. In the case of hormones, we're going to use an example with the pituitary gland. Now remember that the pituitary gland is right up here, right? The pituitary gland is right here in the brain, and it makes a hormone called TSH, right? TSH goes into the bloodstream and travels around, and it targets the thyroid to make thyroxine. You don't want too much thyroxine, right? So we have to control that, and that's what this is going to be about. So the pituitary gland, again, makes TSH. It goes into the bloodstream, and it targets the thyroid. So the thyroid has receptors that receive the TSH. The pituitary gland makes TSH. It targets the thyroid. The thyroid then produces its own hormone called thyroxine. Now, thyroxine targets all the cells in your body to do respiration and other metabolic activities. Okay, so that's nothing new. That's exactly what we talked about, right? The pituitary gland makes TSH. It tells the thyroid to make thyroxine. Thyroxine tells the whole body to do respiration and other activities. But there's something else to it. As the thyroxine level in the blood goes up, it targets receptors on the pituitary gland and says, stop, there's enough. It inhibits it. That's negative feedback. It's just like the thermostat. It's like your pituitary gland has a thermostat. And when the temperature, not the temperature, the amount of thyroxine comes up in the blood, it says to the pituitary gland, stop making TSH. Stop it. We're going to slow down now, right? And so the amount of TSH goes down. And so the thyroid stops producing as much thyroxine, and the level of thyroxine comes down, and then you don't do too much respiration. And so that's negative feedback. All of your hormones are controlled that way, where as the level of the hormone comes up, it shuts off its own production. And when it comes down, it turns on its own production. And that is how hormone levels are regulated.